So this section talks about senses. It's one of my more, I don't know, one of the topics I like a little bit more in this. But the first one we're going to talk about is taste and smell. And interestingly, your taste and smell, these receptors, they work almost the same way and they're in completely the same place. You can see smell particles, they try to draw it, and taste particles. They're right here. They work the same way and they function almost the same way and they're in the same place, which is why smelling is so important to tasting and the foods that we want and want to eat is because the receptors are so similar and in the same spot. Interestingly, when I was your age, they used to have this like fake science thing diagram of the tongue, and they would say, well, you can taste sour here and salty there and sweet here, and you would do these like tongue lab experiments, and I don't know. Anyways, since then, they have found out that that was all completely bogus science and incorrect. And so I'm just telling you that because science changes and the scientists find out they were right or wrong about different things. But you'll still hear some people like my age that haven't heard that that's changed that will miss that. Sometimes they're like, no, you can taste this here, this there, and yeah, you can tell them to fact check that because it's no longer correct. Okay, so we're going to move on to sight, and I want to point out light first comes in through the cornea, and the cornea will focus the light right here onto the retina, and the retina is here in the back, and if your cornea was damaged, what would happen? Well, this cornea here, this really thick piece here, if the cornea was damaged, it could block light, it could distort light, it could even cause blindness. So let's talk about the different parts of the eye. So you have this cornea, and the cornea is transparent, meaning like light can get through it. It's a thick, thick layer, and it helps focus light onto the retina. That's its job. Okay, we're going to move up from there and do the pupil next. The pupil is literally a hole, um, but it's an opening that can get bigger or smaller to let in more or less light. And what helps it get bigger or smaller? Well, it is actually the iris, which is around it. And the iris um, has muscles that make it, that can flex, and it makes things bigger or smaller. So that is the iris. Um, what else do you need? Okay, moving on, we'll do the lens. The lens will flip objects and it will projects it onto the retina, and the retina is here in the back. It has two different types of cells in it called rods and cones. The rods are light sensitive and pick up more grays and blacks, and the cones pick up more colors. So that's how you can translate those things. And then you have this thing that's like a blind spot here. And the blind spot is your optic nerve. And this is like a neuron, just like we learned in the previous section, but it's a nerve that carries messages up to your brain. So this is the eye. So with the next sensation you have is like hearing and balance. Um, so the canals in your ear will in your inner ear are responsible for your balance and for your equilibrium. And I actually feel like this is a better picture. Let me think. Um, maybe here? No? Here? Yes. Okay. So here's a picture of the inner ear. So the picture of the inner ear, this is a little bit out of order. It's misnumbered. It should say 1, 2, 3, 4, 5, 6, 7. And I put this website on Canvas so you can check it out. It also helped you answer one of the questions in the back of the book. Okay. down here it gives an explanation of the pathway. But the general explanation is that sound travels in as a sound wave to the outer ear and then down the ear canal. It will go to the eardrum, and there's tiny little bones there. There's like a drum that's pulled tight, and it's very thin, and these tiny little bones actually tap, get vibrated based on this sound wave that comes into your ear. And then that goes into the cochlea, which is full of fluid and has different hairs in it. And as the hairs move, they actually send a sensation up this auditory nerve so that you can hear and process that. So this is the picture in the book, and I like it, but I just like the numbering of the 1, 2, 3, 4, 5, 6, so you know what's going on. So I think that is everything you need to know there. Now I don't believe it's a question in your book but for people that do not have the best balance, that's actually a sensation that you have too. And inside you have semicircular canals, and those are positioned at different angles and also have fluid and hairs in them. And as you get off balance, the hairs inside of these fluid filled areas kind of bend, and just their bending sends a message up your neuron to go to your brain saying, hey, I'm up, I'm down. And so if you have a problem with balance, you can blame those semicircular canals. Okay, so the next one is touch. You have all these different types of receptors. Why? Why would you have so many different types of receptors for touch? You have cold, and that's kind of deeper inside. Light touch, like you're barely being touched, is right on the edge of your skin. Well, that makes sense, because if you're barely being touched, you need to be able to feel it. You have receptors deeper in your skin to feel like heavy pressure, like I'm playing volleyball and it's like really pounding on my arms or hands. And then heat is like less deep in your skin than cold. So why do you have all these different types of stimuli? Well, you have them all, again, for form, fitting, and function. Form fits function. They are where they need to be based on the different sensations they are trying to pick up. If you had a receptor that detected light touch and it was way deep in your skin, well, you would never feel light touch. So it has to be closer to the edge. And heavy pressure needs to be deeper down, because otherwise it would be too sensitive. Okay, so when your body does get injured, your brain actually responds by sending, well, yeah, basically chemical messages are sent to the injured cells to help make them even more sensitive to pain. And that's so you kind of guard and protect it, protect that injured area. So you end up getting a higher sensation in places that are injured for a little while until it's better, so that you baby it and protect it. I think that's all we need to go over in this section, and then we'll move on to the next one.